Hello. So today I'm going to be doing a showcase solve, and the story behind this is during my live stream yesterday. I needed to find a puzzle to solve because no one had a suggestion, so I looked through the recent archive on the Discord and found a Lisztes puzzle with no solves on it. So I figured, oh, maybe I should give this some visibility because his puzzles are always great. And so I pulled it up, and we, as a collective, attempted to solve this puzzle and completely failed after 45 minutes. We basically didn't have anything entered. We'd figured out a few things about the puzzle, but basically hadn't even broken into it. So what I decided to do was just move on to a different puzzle and ask Lisztes later how to solve it and make a showcase video, because there was a lot of interest in seeing how it was intended to be done. So this is what I'm doing today. And if you haven't watched any of my live streams or are able to show up, I definitely think it's been a lot of fun. So they are also archived, so you can sort of watch some of it to see if that's something you'd enjoy. Definitely recommend it. I always stream every Saturday evening for me, which I live on the west coast of the United States, the PST time zone. So in UTC, that's Sunday at 3 a.m. And then I always stream for at least 6 hours, and lately it's been going for 8 or 9 hours. So anywhere from, that start time to 8 or 9 hours later, feel free to drop by and, help solve some puzzles. And so with that, I will get started on this showcase. And I guess I should go over the rules first. So this is just standard Sudoku, standard Killer Sudoku, and standard Arrow. So what that means is the killer is what these boxes are called. So we have these dotted boxes around the grid, and there's a little number on the top left corner. So if we were to take all the cells of the box, say this one has 2 cells, and you sum those together, that would sum to this number, in this case 10. So these two sum to 10, these two sum to 9. Additionally, numbers cannot repeat in a killer cage. So for example, these 45 cages here, if I put, say, a 1 here, I can't repeat a 1 down here, even though Sudoku rules would allow it. Killer Sudokus don't, because you can't repeat. And I might as well say now, the 45 cages with 9 cells, that's pretty obvious that you end up with the digits 1 through 9 uniquely, just like a regular box of a Sudoku, because 1 through 9 does add to 45. Additionally, we have these arrows with a circle at the end. So if you take the cells that are actually on the arrow and you sum them up, they sum to whatever value is filled in the circle. So if I were to put, say, 1, 1, 2, 3 on this arrow, then that would put a 6 on the circle. And those are the rules. And with that, you should be able to solve this puzzle. Although I do say it is very hard. As I said, we, as a collective on the live stream, several people got together trying to solve this with me at the steering wheel, but certainly not the only one providing logic. And we were not able to solve it. So don't feel bad. If you want, you can watch, you can try it yourself, see what you can do. If you're not able to solve it, you can come back and watch some of this showcase. There's definitely sort of break-in logic to get you going, and then you can see how far you get there, and then there might be some points where you get stuck. Just come back, watch till you get unstuck. I definitely recommend it. This puzzle is actually a lot of fun once you understand the logic. So yeah, feel free to do it however you want, or you can just watch this. The logic is interesting, even if you're not doing it yourself. So with that, I will get started showing you how to solve this. So the first thing, and of course the link is below in the description. You probably know that by now. So the first thing about this puzzle is I'm going to highlight these two 45 cages in green. And what can we say about the green highlighted cells? Well, what we know is that we have the digits 1 through 9 twice. And that should be fairly clear because, as I explained, these 45 killer cages, there are 9 cells. You can't repeat a digit. So it's just like a row or a column or a box in the Sudoku where you end up with 1 through 9 uniquely. And then we have 2 of those. And so we have 2 sets of 1 through 9. So now what I'm going to do is I'm going to highlight this box here, box 5, and row 7. So I'll highlight those in blue. Now, what can we say about the blue cells? Well, the blue cells are one full box of the Sudoku, that's 1 through 9, and one full row of the Sudoku, that's 1 through 9, with no overlap. So this also has two sets of 1 through 9. So now what I'm going to do is I'm going to highlight where the green cells and the blue cells overlapped. I'm just going to color those purple. So what we basically have is we have the set of blue plus purple and the set of green plus purple is the way to think about that. And now if you look, we can actually see where the title of the puzzle comes from, which is .O-T-O dot, because we have the dot, we have an O, we have a T, we have an O, and then another dot. So that's the name of the puzzle, and I'm guessing it was supposed to be a hint to what you were doing, but more likely it's once you find this pattern, then you go, oh, that's why the puzzle's named that way. At least that's what I did. We did not find this on stream. So already, if you know this, you might already have some idea of how to continue. But let me go over it. So green plus purple is two sets of the digits 1 through 9, and blue plus purple is also two sets of the digits 1 through 9. So what we can say is that we can subtract purple from both sides, right? And what we can end up with is the exact digits that are in the green cells, notice it's 8 digits, is the same exact digits as are in the blue cells. There's 8 of those as well. It may not look like it, because these are compact and this is spread out, it doesn't look like the same number of digits, but they both have 8 cells. So we can see we have 1, 2, 3, 4, 5, 6, 7, 8. So the reason, again, let me justify that again, just in case you don't get it. The green plus the purple is two sets of 1 through 9, and the blue plus the purple is two sets of 1 through 9. If I remove the purple cells from either of those sets of 1 through 9, I've removed the same 10 purple cells from those. The same exact purple cells were removed from two different sets of 1 through 9, leaving the same exact leftovers into the blue cells as it leaves in the green cells. So hopefully that's clear. I know I'm maybe over-explaining it, but it is the break into this puzzle, so wanted to make sure that was understood. So what that means is, again, the green cells and the blue cells are the same digits, which means they sum to the same value. That should be clear. Now, if we look at how these arrows are positioned, how do the arrows work? Well, these 3 cells add to what's in this single cell, and these 3 cells add to what's in this single cell. So what we can do is if I were to subtract these 3 cells from the greens, I could preserve that sum in the blue cells just by subtracting this 1 cell. And then same on this side. If I subtract these 3 cells from the greens, I can now subtract this 1 blue cell and preserve the sum in both. And so what that means is the sum of these 2 green cells is the same as the sum of these 6 blue cells. So go ahead and rewatch that if you didn't get it. And it seems a little outlandish that 6 cells would sum to 2 cells, but it is possible. And I'm gonna re-highlight these because we're gonna need this further. But what that means is whatever we put in these 2 cells is the sum of all of these cells. So let's figure out what these can minimally sum to. Well, these all share a box, so they could be 1, 2, 3, 4, 5 at minimum. And 1, 2, 3, 4, 5 sums to 15. And this one, of course, can just be a 1. So in total, this sums to 16. Now, what can these 2 cells sum to maximally? Well, if they were 8, 9, they would sum to 17. And the only way to sum to 16 would be a 7, 9. So what we know is that at minimum, these sum to 16, which would be 7, 9. And at maximum, they sum to 17, which is 8, 9. So there is a 9 in one of these 2. The other one is a 7 or an 8. And then these blue cells, we only get to add 1 more to the total. If we add 2 more to the total, we won't be able to achieve that sum in 2 cells. Like if we made this sum to 18, we couldn't do 2 9s here because they see each other. If we made it sum to higher than 18, well, you can't even do that in 2 cells in Sudoku because you can't put a 10. So what that means is that this 1 could become a 2, or any of these 5s could become a 6. So I'm guaranteed to have 1, 2, 3, and 4 somewhere in these blue cells here. And then they are accompanied by either a 5 or a 6. And then this is either a 1 or a 2. So I'm allowed to increase one of them by 1. I'm allowed to increase either the 5 to 6 or the 1 to 2, or I could sum to 16, in which case this would be 7, 9. So hopefully that much is clear. And so what we can see here is that if we remember, the green cells and the blue cells, all 8 of them, are the exact same numbers as each other. So if this is 7, 9, or 8, 9, no matter how it comes out, they're not going to be in these blue cells. So the only place we can put them is actually in the sums of these arrows as the same value. So these two are represented here. We don't know which order they're in. Like this one could go here, or it could go here. And the same way, this one could go here, or it could go here. But whatever's in these two ends up in these two, because it's the only place in the blues that they could end up. All right, so now I'm gonna get rid of these purples because they're just kind of in the way. But what we want to look at is column 5, and we're going to be focusing on column 5 for quite a while now. So the first question to ask about column 5 is, where does 9 go? So if it were in box 2, 9 would have to be the sum of this arrow. Otherwise, it can't be in any of these blue cells. That would just blow out the sum, right? We're allowed to change a 5 to a 6, but we can't change a 5 to a 9, right? And so otherwise, it would be in the 13. So what we can do is we can check to see, well, is it in the 13? If it were in the 13, in order to add to 13, we would have to be 4, 9. That would put the 9 here. And so then the question to ask would be, well, where now does 8 go in the column? And so 8 would have to be the sum of this arrow, because obviously if the 8 went on the arrow itself, how would we get a bigger number? We've used up 9. So 8 would go as the sum of the arrow. How do we achieve 8? Well, we can count the ways. So, well, I guess the other thing would be, where does 7 go now? We still don't have a 7. And so we'd have to put 7 on the arrow, making it 1, 7, 8. So just the fact that the 9's in the 13 cage forces all this. And so now what we can do is we can see the effect that this has on the blue cage. And hopefully you can already see the problem, but I'm going to walk through it. So first of all, this 1, 7 immediately uses up our 1 degree of freedom. This would have to be a 2. There's no other choice. And so these would be adding to 17, and they do so because this one's a 2, which means we no longer can have a 6 in the blues. That's just not possible. That would use up too much of the sum. Additionally, 1 can't be down here, so 1 would be in one of these 2 cells. And 2 can't be here, so 2 would be in one of these 2 cells. So far we've got 1 and 2 here. But also we have the 4, 9, so 4 can't be here. So now 4 would have to be in one of these 2 cells. And you can probably see the issue. So I could have described that a bit more succinctly, but I wanted to show the problem, which is that we've removed too many values from this column. We can only be, because this is a 2, we can only be 1, 2, 3, 4, 5 along here, which means we have to use 3 of the 1, 2, 3, 4, 5, and we've removed the 1, the 2, and the 4. That's removed too many. We've removed 3 of the 5 digits. So this just doesn't work. Which means we actually know where the 9 goes. The 9 goes up here. So we're going to continue looking at this 13 sum. We know we need an 8 somewhere. So let's see what would happen if the 8 were in the 13 now. So that would put 5, 8 here. So with a 5, 8, we of course need a 7. So that would force 2, 7 to be the 9 sum. And so now what we can do is we could clean this up. Actually, we will clean this up. So this 2, 7 does put a 1 here. So our degree of freedom isn't used up. We can still use a 6. The 2 is removed from here, and the 1 is removed from here. So ignoring my corner marks here, that would actually force 1 and 2 out into the wings, because we have to have a 1 and 2 somewhere in here. So I guess maybe I will use my corner marks here. But additionally, the 5, 8 removes the 5. And so again, we can make a few observations about this already. This does look possible, but it adds to 17. So these would be 8, 9s. The 1, 2 is in the wings. And the final thing I'm going to point out is, what does that do to box 2? Well, let's look at what numbers are remaining. So, and in relation to whether they can go in the 12 cage. So I need a 1. 1 can't go in the 12 cage, so 1's going to have to go outside the 12 cage. 2 is used. We need a 3. 3 could go in the 12 cage, but only if it was with a 9, but it can't. So 3 can't go in the 12 cage. With a 4, I'd have to be with an 8, which is possible. So we're going to add 4, 8 there, but 4, 8 could also be outside. With a 5, I'd be with a 7, but 7's used. So actually 5, 7 would go outside. And then 6 can't be in a 12 cage because it would have to be with another 6. So let's put a 6 out here. And actually now you can see, actually I shouldn't have put a 7 here because of the 2, 7. But now you can see that the 4, 8 is the only option for the 12 cage. So we can remove 4 and 8 as options here. And now for the 9 cage, how do we add to 9? Well, 3, 6 is the only way to do it with these possibilities. We can't use the 5 because we don't have a 4. Can't use the 1 because we don't have an 8. So 3, 6 would be the total there. So what I want to point out here is that the 9 becomes a 3, 6, and we have 1, 2s in the wings, and this sums to 17. We could remember all of this, but that's all I want you guys to remember. So the other possibility for where 8 goes, let me keep on doing. If 8's not down here, guess what? 8's up here with a 1. So that would obviously be 1, 8 here. And so then the 13 sum would have to use the 7, and so that would be 6, 7 to add to 13. So what is the consequence of this? Well, 1 and 2 are again removed from the center and forced into the wings. Additionally, we have the 1, 8 here, so that forces this to be 2, and the 6, 7 removes the 6 here. So we're still good, but we do add to 17. We only use the 1 degree of freedom here. We add to 17, and so these again would be 8, 9, adding to 17. This again adds to 17. 1, 2 is again in the wings, and then now we can do the same thing of figuring out how this box 2 gets arranged. So 1 is used, 2 can't go in the 12 cage, so 2 has to be outside. 3 would have to go with a 9, so again 3 is on the outside. 4 would have to go with an 8, that's not possible, so 4 goes on the outside. 5 would go with a 7, so that could be 5, 7, but also 5, 7 could be outside. And then 6 is the last one. Again, 6 can't go in a 12 cage because it would have to be with itself, so 6 can go on the outside. And so now this actually means the 12 cage has to be 5, 7, so we can remove 5, 7 from the rest. And again, we look to see how we add to 9. Well, we can't be a 2, 7, so 2's out, and we can't be 4, 5, so 4's out. And so again, if you remember, oops, wrong way. If you remember, this 9 ended up as a 3, 6. So in all of our cases, and I'm just going to leave this here, I'm not going to undo. In all our cases, this added up to 17. Because these were the two paces, right? Either 8's in the 13 cage or 8's on the sum. There's nowhere else to put the 8. So those are the two options. And either way, we sum to 17. So these can't be 7. We have to be 8, 9s to sum to 17. And if you remember, whatever's in these green cells goes here. So whatever we do to these green cells, we have to do to these arrow sums as well. Additionally, this 9 cage ends up 3, 6, and 1, 2 ends up in these wings. The rest, though, was not consistent. So we're just going to delete these here. And if we remember, we either had a 1 or a 2 here. The way we used up our degree of freedom was either by putting a 2 here and then not a 6 here, or we put a 1 here and not a 5 here, and we put a 6 here. So hopefully that's clear. So we still have to have a 3 or 4 now down through this column in box 5. The 1, 2s are in the wings, and this is 1, 2 as well. So the next thing I want to do is talk about these arrows. So we know that one of them is going to add to 8 and one of them is going to add to 9. So in addition to that, the way that they add to 8 and 9 is by taking the values that are in these blue cells and splitting them up into 2 sets of 3, one of which adds to 8 and one of them adds to 9. All right, so here I have a notepad up. And what we're going to do is we're going to write down all the values that we could use to add to 17 with these blue cells. And what we have to do is we have to split up those values into 2 groups of 3, one of which adds to 8, one adds to 9. We don't know which way that goes. We know that's how they're going to get split up. So there's actually 2 possibilities here. This is either a 1 or a 2, right? So if this were a 1, that bottom cell would be a 1. What would it be accompanied with? Well, it would always be with another 1 and 2 in the wings. And then in order to add to 17, we'd have to use the 6 instead of the 5. So it would be 3, 4, 6. The other way that we're going to be adding to 17 is if this were a 2. So we'd have a 2, and then I'm going to just put a 1, 2 in front of that for the 2 in the wings. So we have 2 2s, and then we have to use 3, 4, 5 here. We can't use the 6. So this would be a 3, 4, 5. So those are the 2 ways that we can have this T adding up to 17. So now what we can do is we can try to split these up into 8s and 9 sums. So for this sequence here, an 8 always has to have a 1 in it. So we can actually just start by taking the 1s out and putting them in the 8s. And the reason 8 always has to have a 1 is 2 plus 3 plus 4 is equal to 9. And so if you exclude the 1, that's the minimum you can do, and that's already too much. So the 8s are always going to get a 1. So now the question is, can the 8 take the other 1? Well, no, because we can't repeat, right? So in this case, the other 1 goes with the 9. And so now we are down to 2, 3, 4, 6. How are we going to add to 8? Well, we can't do 1, 2, because 1 plus 2 is 3. We'd need a 5. So the 2 has to go with the 9. And then here, the 6 with the 1 would require another 1. So in order to add to 8. So the 6 also goes with the 9, and that leaves 3 and 4 for the 8. So the 8 would be 1, 3, 4, and the 9 would be 1, 2, 6. The other possibilities here, well, obviously we have to split the 2s up because you can't repeat a 2 with 8 or 9. And so that just finishes it because now we have 1, 2 adding to 3. We have to use the 5 to add to 8, and then the 9 gets the 3 and 4. So we're either, these arrows, the only possibilities are we either have a 1, 3, 4 with a 1, 2, 6 for whichever one's 8 and 9, or we have a 1, 2, 5 with a 2, 3, 4. We can't mix them up. We can't do like 1, 3, 4 and 2, 3, 4 because that wouldn't use the correct sequence of digits that have to be equal to the digits in the T. So the next thing I'm going to look at then is box 4. And we're going to see what's actually possible to do in box 4 because it has this 10 cage and it does a really interesting interaction. So the first thing to point out about a 10 cage, if you're not aware, is that there's always one low number, which is 1 through 4, and one high number, which is 6 through 9. If you think about it, you can't do 2 numbers between 1 through 4. That would never add to 10. You can't do 2 numbers that are 6 through 9. That would add to 12 or higher. You can never have a 5 in a 10 cage because you have to repeat the 5 to make 10. So it's always 1, 9, 2, 8, 3, 7, or 4, 6. So you have one that's 1 through 4, one that's 6 through 9. So I'm just going to pick one of these to be the 1 through 4 and one of these to be the 6 through 9. It could be the other way around. It's not going to affect our logic here. So the question is now, what would happen if I used up 3 of the 4 lows on my arrow? And so in that case, that would be if it were an 8, it would be 1, 3, 4. If it were a 9, it would be 2, 3, 4. Well, 3 of those would be used up, and that would force this 10 cage. So 1, 3, 4, for example, uses up 1, 3, and 4, and that would put 2, 8 in the 10 cage. But 1, 3, 4 adds to 8, and I'll put an 8 here as well. So 1, 3, 4 is actually not possible here. So if there's going to be a 1, 3, 4, that's going to be paired with a 1, 2, 5. And the 1, 3, 4 would have to go, or sorry, that would be paired, the 1, 3, 4 would be paired with the 1, 2, 6. So it would have to go 1, 3, 4 here and 1, 2, 6 here. And notice this doesn't use up all 3 lows, so that's fine. The other option, and so that this would add to 9, this would add to 8. The other option is if this adds to 9, we can't use 2, 3, 4 for the same reason, because 2, 3, 4 would use them up. This would have to be 1, and that would pair it with a 9, but 2, 3, 4 also adds to 9. We'd have 2 9s in the column. So if we add to 9, we have to be 1, 2, 6, right? So what that means is the 2, 3, 4, if this one were the 9, the 2, 3, 4 would be here. So just to explain that, so this would be the 1, 2, 5. So hopefully that's clear. I can explain it in a slightly different way, which is we're going to have an 8 and 9. So like if this were 8, this can't be 1, 3, 4. So if it were 8, it would be 1, 2, 5. If this were 9, it can't be 2, 3, 4. So if it's 9, it would have to be 1, 2, 6. And whichever one it is, the other pair goes on this side. So if this were 1, 2, 5, the pair is 2, 3, 4. That would go here. If this is 1, 2, 6, the pair is 1, 3, 4, and that would go over here. So what we can say is this always has a 1 and 2 in it, and this always has a 3 and 4 in it. And the wild card is whether this is 1, 2, 5, or 6, and whether this is 3, 4 with a 1 or a 2. So hopefully that's clear. You can get rid of that notepad now. And either one of those will end up using the exact digits that are in our blue T. So next, what I'm going to do is I'm going to get rid of this coloring because we've used it up. We will want to remember maybe a little bit later that this relationship still exists, but for now, we can forget it. And I'm going to show you another very similar relationship. And this is something that actually, if you're familiar with Windoku, which I haven't covered on this channel, but Windoku is a common variant of Sudoku. And Windoku does make use of this trick a lot. But I'm going to just explain it through normal set theory. So I'm going to highlight these all in green. So I've highlighted 3 rows. And just like before when we were talking about 2 sets of 45, this is 3 sets of 45. Because we have 3 rows. This row has a 1 to 9, this row has a 1 to 9, this row has a 9 to 1 to 9. So to say more exactly, we have 3 1s, 3 2s, 3 3s, all the way through 3 9s. So now what I'm going to do is I'm going to remove 1 set of 1 to 9, but I'm not going to remove a row, I'm going to remove a 45. So here, I've removed 1 set of 1 through 9, because we know there's a set of 1 through 9 in this 45 gauge. So now I'm down to 2 sets of 1 through 9, and now for this 45 gauge, I'm also going to remove it. So now I've removed the second set of 1 through 9, and I'm left with a set of 1 through 9 in the greens. So the greens act like another kind of 45 gauge or extra region, or however you want to think about it. But there's exactly 1 of each of 1 through 9 in the green cells. So I'm gonna get rid of this because this is left over. Let's not get confused. But the question we can ask is, where do 1 and 2 go in the greens? So one of them goes here. That much is clear. But where does the other one go? Well, first of all, it can't go in either of these 2 greens because we just marked that 1 and 2 have to be on this arrow. So these 2 greens are out. These obviously don't have 1 and 2. These don't have 1 and 2 because they go on the wings in this box. And so 1 and 2 is limited to these 2 greens, but you can't have an arrow head have a 1 or 2 because how would you add? You certainly can't add to 1 in 2 cells. The only way to add to 2 in 2 cells would be to repeat a 1. And so this actually is a 1 or a 2. And so now if you actually look at box 6, we have a 1, 2, 3, 4 quadruple. And so what can this arrow sum be? Well, the arrow sum is in the greens, and there's an 8-9 pair in the greens. There's also a 1-2 pair, but that doesn't matter. There's an 8-9 pair in the greens. So, and it can't be 1, 2, 3, 4. So if it can't be 1, 2, 3, 4, 8, 9, that leaves 5, 6, and 7. How would we add to 5? Well, the only way to add to 5 would be putting 2, 3 on the arrow or 1, 4 on the arrow, but that would require this cell to be 1, 2, 3, or 4. So another way to put that is, what's the minimum of this cell? It's a 5. So we obviously can't add to 5 because this is a minimum 1, and so that would add minimum to 6. And so 7 is our max. So with a 5, we could be with a 2, or we could do 6, 1. So these are actually the only values available in these cells. That actually does make a 1, 2 pair, which is quite nice. Can't be used quite yet. Additionally, what we can say is that this 10 cage here, because the 1 and 2 are taken, we only have 2 options for the sum, which is we can be 3, 7, or we can be 4, 6. So we'll just mark that. And so now what we can do is we can look at row 5 here, and we can ask, where do 8 and 9 go? Well, now we've excluded it from here. They're excluded from the arrows, and they're excluded from this sum. So 8 and 9 must go here in this row. So it's a hidden 8, 9 pair. And the next thing we're going to do is focus on row 6 for a bit. So first, what can this cell be? Well, we have a 1, 2 pair and an 8, 9 pair in the greens, so we can't repeat those. So we have to be 3, 4, 5, 6, or 7. And so also for the rest of row 6, we're going to ask what these two can be. So let's take a look. Again, we have the 1, 2, 8, 9, except this time in the box. We also can't use 3 and 4 because they're required in the center column. And so we can't be 1, 2, 3, 4. We can be 5, 6, 7. We can't be 8, 9. So this is actually, these cells are a bit more limited than we expected. The next thing I'm going to point out is for these two cells, if this one were a 5, well, I guess, first of all, there's a 3, 6 here, so this can't be 6, right? But if this one were 5, if you think about it, it has a huge effect on this row, because if this were 5, in the box, it removes the 5 from this cell. And in the 45 cage, it removes a 5 from the arrow. And now there's nowhere to put a 5 in the row. So this cannot be a 5. I guess another way to put that is, where can 5 be in the row? It can only be in these 3 cells. All 3 of those cells see this cell. And so they eliminate 5 from here. The other thing to point out is this can't be, can we not have a 7, right? If we don't have a 7, then this is 5, 6, and that removes both 5 and 6 from the center column. That's obviously not going to work. We'd end up with 5 cells for 4 numbers. So there must be a 7 in one of these 2 cells. So that means we can eliminate 7 from here. We're down to 3, 4, 5, 6. And we're actually gonna eliminate a couple more numbers. So can this be 6? So if this were 6, it does affect these 2 cells, right? It would make this a 7 and this a 5. And that has a really interesting effect here. So the 5 removes a 5 from these cells. And if you remember, these cells had to be represented in these arrows, which means we have to put a 6 somewhere in these arrows. But this 6 in this box removes the 6 from the only place they can be on the arrows. And so that causes a contradiction. We're not going to be able to put a 6 on the arrows. We're not going to be able to put a 5 in this column. So that's just not going to work. So this cell can't be 6. Next question is, can it be a 5? Well, 5 causes this to be a 7 and this to be a 6. That does the exact same thing. It removes the 6 from here, leaving just 5, but it removes the only place the arrows can have a 5, and it puts a 6 on the arrows, and there's no 6 here. So it's the exact same thing. This cannot be a 5. So we're actually down to 3 or 4. And if you think about it, the 3, 4 is now paired with whichever one of these 2 cells is also a 3 or 4, because remember there's one low, one high. So the 3, 4 is paired up in this box with another 3, 4. So 3, 4s are used. We can't have any more 3, 4s. So 3, 4s can't be here. 3, 4s can't be in these 2. If you remember, on this arrow we had 3, 4s, so 3, 4s can't be in the top row here. So 3 and 4 are actually limited to 2 cells in row 4. So this can't be 5 or 6, and this can't be 6 or 7, because otherwise we wouldn't have enough places to put 3 and 4 in the row. That's a hidden pair. And so if this is 3, 4, that means this is 6, 7. And that causes a 6, 7 pair. The 6, 7 pair is both in the row and in the greens. So what we can do is we can remove the 6 from the rest of the row, that's just here, and we can remove 6 and 7 from anywhere in the greens. And guess what we just did here? We have no more 6s available in our T. And so what that means is that we are 1, 2, 3, 4, 5 here. We also removed the 6s here, so that should be pretty clear. And we know we have to add to 17, so that means this is a 2. That forces this to be a 1, because again, the greens can't repeat digits. That 1 forces this to be 2, and 2 can't be paired with a 6, so that's a 5 and that's a 7. That makes this a 6. 6 has to be with a 4. That makes this a 3. We no longer need a 3 here. That's a 4, 5 pair. Additionally, this 1 is used up in this box. This is a 2, 3, 4. So 2, 3, 4 adds to 9. We could have done this a while ago. 1, 2, 5. Because we don't have the 6 anymore in the T. So 1, 2, 5 adds to 8. And we are off to the races, right? So now, if you remember, we had 2 options for column 5. I don't expect you to remember how they went, but we can figure it out again. Because now we know this is a 2, and there's no 6 here. We're going to have a 6, 7, and 8 outside in these sums here. So with 6, 7, and 8, how am I going to make 9? Well, with 6, I need a 3. That's not going to work. With 7, I need a 2. That's not going to work. So the 9 has to be 1, 8. And that leaves 6, 7 for the 13 sum. Additionally, we had figured out this box as well. So we'll just figure it out again. So we can't have a 2 in the 12, so the 2 is going to be outside the 12. We can't have a 3 in the 12, so we have a 3 already in the box, right? 4 would go with 8, but 8's used, so the 4 is up here. And that should hopefully leave something that adds to 12, which is 5 and 7. And then that indeed does add to 12. So this 5, 7 pair here does C down. That causes this to be a 6. And if you remember, we have to have a 7 here, so this is the 7. And next what we can do is look at this 10 sum. This column's practically done. So what's remaining in it? We need a 3, 4. We have a 5. We need 6 and 8. So how are we going to add to 10? Well, we can't use a 3 because we don't have the 7. 4 can go with 6, can't use the 8 because we don't have a 2. So this is going to be 4, 6, and this is going to be 3, 8. And this 2, 4 pair actually tells us which way around the 4, 6 goes. We can also look at the other 10 in this box. So if we were 1, 9, we would be this way. Actually, the other way. We'd be 1, 9 like this because of this 9 here. We cannot be 2, 7. We can't be 3, 6. And we can't be 4, 5. So actually this 10 cage must be 1, 9. And of course these ones C down and forces a 1 somewhere here, but we don't need to mark that yet. The other thing we can do is we actually can, we have a triple and a double and a filled digit in both of these top 2 rows of the 45 cages. So we can just fill a triple. So this triple is going to be 3, 4, and 7. And this triple is going to be 1, 5, and 6. You can see here the 3, 6 C's down here. Whoops, 3, 6 C's down here. And the 5, 7 C's down here. And so there must be a 7 in one of these two, and there must be a 6 in one of these two. That's going to come in handy. Next, what we can do is look at, oh, we have this 4 here. Sorry, didn't fill the 3. I'm sure you've been looking at that. But we can look at this column now. So let's look at what's actually remaining in this column. So we need a 1 and a 2. We have 3, 4. We need 5, 7, and 9. So obviously these arrow points, as explained earlier, cannot have a 1 or 2 on them, because how would we sum to that? Additionally, the 7 can't be down here because we have the 7 filled in one of these two. So these can't be 7. So that means we actually have to have a 7 up here. And the option is for the 7 to be on the arrow or for the 7 to be on the sum. Either way, there's no way that it sums to 5. And so we're 7 or 9. How are we going to do that? Well, we obviously can't. We could never have had a 9 on the arrow shafts. Can we use a 1? Well, we don't have a 6 and we don't have an 8, so the 1 can't go here. So we're actually going to be either 2, 5, 7, or we're going to be 2, 7, 9. So we always have a 2 down here as well. And if you look at the column, where does 1 go? It must go here. Okay, so next what we're going to do is look at row 9, and we're going to see how these arrows interact with each other, along with this 6, 7 here. So there's a bunch of different ways you could see this, but basically what we're going to do is we're going to basically ask, can this be a 3? So the other thing to ask, which may be more fruitful, is in these 3 cells, or rather in this row, right, we have one of 6 or 7. Where does the other 6 or 7 go? Well, it clearly can't go in these 2 cells because the 6 or 7 is, there's already a 6, 7 pair in the box, right? So it doesn't go in these 3 cells. And these can't be 6 or 7. And so 6 or 7 is going to go on one of these arrows. We don't know if it's a 6 or 7, but if it went on this arrow, it would have to be a 6 because our 7 is used. So if we had a 6 on this arrow, we obviously couldn't add to 5, so we'd add to 9 and we'd use up a 3. So this couldn't be 3. The other option would be on this arrow. It couldn't be a 6, it would have to be a 7. And we still can't add to 3. So since this arrow doesn't sum to 3, it must sum to 8. So we have an 8 here and a 3 here. And so how do we achieve 8? Well, 1, 7 is absolutely possible, and we need it somewhere for a 6 or 7 anyway. We can't do 2, 6 because the 6 is up here. And we can't do 3, 5, and obviously 4, 4 is not possible because we can't repeat the 4. So this actually is 1, 7, and that does a lot of things. The obvious is it points over here. This is 6, this is 7. It also removes a 1 from here, so the only place for a 1 in this 45 cage is now right here. This 1 sees up. We get a 2 and a 1. We get a 4 and a 2. And also what we can do is fill a pair in here, because we have the 5, 6 pair, we have the 1, 7 pair, so the remaining pair is going to be 2 and 4. And so this 2, 4, the 2 looks over here. We know none of these are 2 because of this 2, and this isn't 2, so that actually forces a 2 to be on the arrow. So if we wanted to add to 5, it would be with a 3. If we wanted to add to 9, it would have to be with a 7, but the 7's used in the row. And it's also used in the box. So this is actually 2, 3, and this is a 5. The 5 is now used up here. That forces this to be 2, 7, and the 9 is on top. We also have this 2 here. So this is 7, and this is 2. The 7 gives us the 5 and the 7. Additionally, this 2, 3 pair does clean up 3 from here, does the same thing that the cleaning up the 1 did. So that forces this to be the 3. And so now the solve, it's pretty simple from here. There's not like a specific path to take, but I'll do what I can here. So this row needs a 4. This can't be a 4, so this is the 4. And the remaining digit for the column is a 8 or 9. This should be fillable as well, so we need a 9, so the 9 goes here. That actually resolves this 8, this 9, and this 8. So the remaining digit in this box is a 5. We here also have a pair, so we need a 6 and 9, which are not yet resolvable. Additionally, this 1 here does remove a 1 from there, so there's a 1 in one of these two. But we have 1, 2, 5. The remaining 3 digits, so we have 1, 2, 3, 4, 5, 6. We need 7, 8, and 9. And then one of them has to be a 7. And over here, we have 6, 8, and 9, and one of them has to be a 6. But this one cannot be 9. This 1 here does see down, so that does resolve the 7 and the 1. And next, where does 7 go in box 3? Well, these 7 see in, this 7 sees up, so this is a hidden 7. And the remaining 3 cells are going to be 3, 5, and 8. And the 5 C's over here. And so now there's a 9 in this killer cage, so this can't be a 9. So this is 8, this is 9. This 8 removes 8 from here, making a 7-9 pair. So this can no longer be 9, of course. Same with the 9 being in the box, also removed that. And this 3 here, C is over here, making this not a 3. So now we have a 2-4 pair in the column. That forces this to be the 3. So now this is not 3. So if we look, where does 3 go in row 1? It must be in one of these two, which means this is not a 3-6 cage, which actually forces 6 to be in one of these two. The 6 C's down here, making this 9 and 6. The 9 C's here, making this 7, 9. And the 7 C's down here, making this 4 and 7. And so now where does 4 go? It is actually forced into the 9 cage, making it a 4-5. The 5 here tells us which order they go. And this 5 C's over here, eliminating that. 3-8 pair puts a 5 here. The 5 C's down here, making this 2, 5, and 1. 2 C's down, making this 3 and 2. We need a 3 in this box. It can't be here anymore. It must be here. And this last cell for the column is an 8, making this 1 and 8. This is 3 and 8, 6 and 3. The 6 goes down here. This last for the box is a 1. This 8 C's down, 6 and 8. 6 C's 5 and 6. This 5 C's over here to make 4 and 5, 2 and 4, and 2 and 4. And there you have it. That is how you solve OTO. So definitely a lot of places in there to get stuck. So I don't blame myself or anyone else for not being able to solve this efficiently or at all. Let me know in the comments how you felt about this puzzle. I feel like every step was logical. There were definitely some needed experimentation at certain points, especially with where does 9 go in this column? Okay, now where does 8 go? Now where does 7 go, etc. So let me know how you felt about this kind of puzzle. Definitely, I would say this is probably the hardest puzzle I've featured on this channel. Although there are some contenders, but yeah. Let me know how if you want to see more like this. Please subscribe. If you want to know when upcoming streams are happening, you can also subscribe. I always put up ahead of time a sort of stream coming up video thing, the way that YouTube allows you to do it. So it'll show up in your feed. You'll be able to see in your local time when that's going to be. And other than that, hope you enjoyed the video, and thanks for watching.